Welcome to Type Tune Tint. I'm Tom Kranz. Wasps are terrible. They come jam-packed full of pain and anger, and they love to sting us out of the blue while we're minding our own business. They eat our food at picnics and frighten our children. They even build nests in our gardens and homes just to complicate our already stressful lives. These aren't my words, folks, but the words of today's guest, Chris Alice Kratzer, whose fascination for wasps spawned a fascinating book that she not only wrote but illustrated with more than 900 wasp drawings. Alie's fascination with wasps has gone way beyond writing and drawing, though. It's inspired her to invent a new type of home insulation that has attracted the attention of the National Science Foundation. And one day soon, she hopes will be coming to a home contractor near you. And I'm joined by Chris Alice Kratzer from her palatial estate in Frenchtown, New Jersey. We are sharing a 90-degree plus weather here in New Jersey. I start every one of these podcasts, Alie, with a brief weather report because every one I've done in the last 6 months, New Jersey's either been pouring rain or it's been 90 plus degrees. So people just don't come to New Jersey unless you're going to the beach. So I first met Alie at a book fair in Flemington, New Jersey, on Memorial Day weekend. It was my second year there. This is a book fair that's sponsored by a used bookstore there, Second Act Books, I think it's called. And, you know, all of us local authors, regional authors, we set up our tents and our tables, and we sit there with our piles of books, hoping against hope that complete strangers will be interested in our stuff. And for a while, I was wandering around to see what else was around me, and I noticed Alie sitting at her table with this book, The Social Wasps of North America. And I said to myself, this is a unique book because most of the people who show up at those book fairs write about their personal experiences, lots of personal trauma, DIY, travel, children's books. My God, the children's books. Yikes. So this was like a really unique and different book. Great cover. Look at all the wasps. How many of us just can't absolutely stand wasps and are afraid of them? So I figured there's got to be something here. So Alie, it's nice to meet you a second time, even though it's virtually. Hello again.
My pleasure. Thank you for inviting me on the podcast.
So you wrote this book. It was copyrighted a couple of years ago. I guess you finished it maybe last year. How long did it take? Folks, I'm just going to babble one more second. This book is 400 pages. It has more than 900 illustrations of wasps that Alie did her own self. And she even did a video on YouTube explaining and showing how she did it. Get into that a little bit more. But the detail of this book, the sourcing of the photographs, the showing of what the range is of each one of these wasps. And 900 is not even the total number of wasps in the world, right? There's like thousands more.
Oh yeah, no, there's wasps are one of the most speciose group of animals on the planet. There are at least 100,000 species that we know about, and probably 200,000 that we don't.
Right.
So it is.
And so you picked the social wasps of North America. There's also, what are they called? The solo wasps, or what's the other half called?
Yeah, so most wasps are solitary, which means they go their whole lives pretty much on their own.
Gotcha.
The social wasps, in this context, social just means that they cooperate to take care of each other's young. And I just think that stuff is very interesting.
Well, these are the wasps we also are familiar with, right? Mostly the social wasps.
Yes. So the social wasps are the ones that have given wasps a bad name.
One species of wasp's nest, their hive, as it were, actually inspired you to invent this product, Yellowjacket insulation, which we're going to talk about too. So, ladies and gentlemen, Alie, she's not just a writer, she's not just an illustrator, she's an inventor. And probably in a very short period of time, we're going to be seeing her on CNBC as, one of the entrepreneurs of the future here. I know you laugh, but my wife and I watch the History Channel, and we watch the icons that made America, the cars, the brands that they all start like you. some little guy or some little woman who had this brilliant idea for like peanut butter or something, and they slaved away in their kitchen or their garage or God knows where. And 30 years later, they're like an iconic brand. So that's coming up. All right. So you decided to write this book, but take us back a little bit. So you went to school and you got a degree in mechanical engineering.
I did,
And
yes.
so did you start out as a little girl just being interested in science and insects, or what take us back a few years to how this all started?
Yeah, sure. So, I have always had a love of science and the natural world. Now I grew up here in New Jersey. People typically don't think of New Jersey as being particularly nature focused, but my family lived here in a little house on a hill above the Delaware River. And there were always lots and lots of new and interesting creatures to discover, most of which
Wow.
were bugs. Um,
So you were interested as a kid in bugs and nature and stuff.
Oh, absolutely. Yes. And both of my parents were involved in environmental stuff.
Wow.
So that was a big inspiration for me as well.
Really? So I'm guessing they were supportive of you as you went along.
They certainly were. Yes. Anything to get me out of the house was a
Yeah.
welcome,
And do you
a
have
welcome thing for them.
siblings who went down the same path or no?
Somewhat. I have one brother. He is now a car mechanic. So
Okay.
similar in the sense that we both get our hands dirty, but in
Yeah,
different
so
ways.
he's a mechanical engineer in his own right, I guess, right? All right, so
He would say so, yes.
you went to you went to high school in New Jersey,
Mhm.
and did you like do science fairs and did you excel in science and biology and stuff in high school or no?
Not particularly. I was not a particularly good student in high school. I was more interested in doing my own things than being particularly good at school for a
Okay.
long time. Um, but I did graduate well enough to get into RIT in upstate New York
And
for
RIT is
college.
the Rochester Institute of Technology, right?
It is, yes.
And you went
Uh,
to that school. Why?
so I got to the end of high school and I tried to figure out what I wanted to do for the rest of my life. And that was a almost impossible decision for me because I wanted to do everything, and I still kind of do. There's just so much interesting stuff to do in this life, right? Um, I I had a few ideas of things that I liked. I was interested in art. I wanted to learn more about biology. I wanted to learn more about engineering as well. Um, and of those three, I figured, well, engineering, if I'm able to get a degree in that, will probably open the most doors for me if I choose to do something later in life. And that turned out to be 100% correct. So I'm really glad that I did that.
So then you graduated, you got your degree, and so then you started down. When did you get to really get into like wasps? When did that happen?
So, um, right after I graduated from college, I got hired into industry. I was working for as a manufacturing engineer for Corning, the glass company, specifically in their division where they make catalytic converters for vehicles. Um, and that was fine, but it wasn't really exciting to me because I wasn't like innovating anything new. I was just taking care of equipment that other people had built. Um, so every night, after I got back from work, I would just illustrate some insects for fun. Um, and it turns out, if you do that enough, sometimes you accidentally write a book about it. Um, and sometimes that book spawns off an entire new career.
All right, so you started down this road of drawing pictures of wasps. Okay. And you started writing this book. How long did that take you until you finally got all 400 pages and all 900 illustrations?
So I started the Wasp book in 2018, um, and I finished it in 2022. Uh, as in, I published it in early 2022.
Yeah. So you worked on it pretty steadily, or did you work on it like for a couple hours here, a day here while you were, working whatever day job you were doing?
So for the first few years, I was working on it part-time, just whenever I had extra time to spare. At the start of the pandemic, I was laid off from my position at Corning, and I uh, had a lot of free time on my hands
Mm.
all of a sudden. So that became more of a full-time job for me at that point, and that sort of brought me all the way to publication.
And all of your knowledge about wasps and all the little minutiae in here, the names of the species and the sourcing and all that stuff, where did that come from?
So it came from a couple of different places. Very little of it is like me going out into the field and like looking for them. Um, a lot of it is from reading the work of specialists who have written about this in the past. A lot of it is networking with many other community scientists across the world, and learning about which species are found where and at what times of year and how they fit into the general ecology. Um, a lot of it was also volunteering with museum collections. So when I was working for Corning, a few towns over is Ithaca, which is where Cornell University is. Um, and Cornell University has an extensive insect collection. So some weekends I would go over there to help them sort through their Hymenoptera, the insect group that includes wasps. And it was another very hands-on opportunity for me to learn more about this group. Um, so yeah, basically, my process is just to explore as many different avenues of information as I possibly can and then collate it into one place, um, in order to help me learn and also to pass that information on to other people.
Well, I got to say, I guess this book really kind of, it's a field guide, right? I don't know if that was
Mhm.
your intention, but it is. And folks, I know that maybe getting a field guide to the wasps of North America might not be the first item on your Christmas list. However, if you open this book and start reading just the text part, the preface, the parts on ecology, the parts about avoiding wasps and what to do if you're stung, and just kind of that, it really sucks you in. And it sucks you in because I think that as a species, we humans have this just complete aversion and fear of wasps, even worse than bees, because they've got that hanging torso and they got the big, and they're brown and they're ugly and they're scary and all this stuff. What really fascinated me though is the fact that the illustrations that you did here are just amazing. And tell me, what is the platform that you use to do this artwork?
So when I was starting out, it was hand drawn, but pretty soon I improved the workflow so that I would start out hand drawn and then I would scan in the sketches to my computer, and then I would finish them in a program called Clip Studio Paint, which is a pretty common substitute for Photoshop. It's just cheaper.
Hey, anytime anybody cannot use an Adobe product, I'm a
Mhm.
prisoner of the evil empire. To me, Adobe is the evil empire of creativity because everything's by subscription. You got to pay 68 bucks a month now for a bunch of programs you never use. So God bless, check out on YouTube, Alie is, search her name and then check out the 25-minute video on how she does this. It's just amazing.
I was particularly fascinated with a species called the Arctic Yellowjacket, which builds spherical paper nests within permafrost high
Okay.
above the Arctic Circle. Um, and though I did not study these nests in person, I was able to examine a lot of community science photographs and coordinate with other scientists that are up in that region to get more information. Um, and the reason this is so interesting to me is because these wasps can somehow survive inside of this nest, inside of the permafrost, without freezing to death. Um, which made me think, from my engineering background, okay, either there's some sort of biological adaptation that is preventing, like chemically preventing these wasps from freezing, or there's something special about the nest that is preventing, or at least very much slowing down the process of heat flowing through the material. So while I was still at RIT, I started looking into this, just sort of doing very rudimentary research. Now, obviously, we don't have Arctic yellowjackets in upstate New York, but we do have very similar species that construct very similar nests. Uh, other types of yellow jackets in the area. Um, So what I did is I went out and I looked at these nests, specifically ones that had already been used and didn't have wasps in them anymore. And I measured out the distance between each of these paper layers that are surrounding these nests, and realized that it was very consistent across different species. And that made me very, very curious to know if there was indeed something special about this. Um, Fast forward till after I got laid off from Corning. Um, while I was working on my first book, The Social Wasp of North America, I was also I put together a small team of other alumni from RIT um, to try to explore this and some other ideas that we had and see if any of uh, these ideas that take inspiration from nature could actually be useful to people. Um, and the insulation, as I'm sure we'll talk about later, did indeed work the way that we expected it to. The wasps were right about this one.
There's another invention also that you put on hold, I guess, the whole wind turbine thing, which is a great piece of video. We're going to talk about Alie the inventor in just a minute after this word about this great new novel that just happened to be written by me called Wreck and Return. Folks, don't go away. And we're back with Alie Kratzer talking about, wow, the mind of a mechanical engineer. I have a little bit of simpatico here because my brother-in-law, who you met briefly at the book fair, by the way, has a master's in mechanical engineering, and he actually is a public school teacher in Philadelphia. He teaches in this kind of select group called the Student Leadership Academy. He teaches an engineering class among kids who are actually interested in STEM, in science and technology. And he makes all kinds of Rube Goldberg machines. And, at the high school level, they do all kinds of stuff that just reminds me actually of the little invention that you made, the wind turbine. So I'm going to make sure that John sees this episode because he's going to love it. But so you had this idea, and now you have this product called Yellowjacket, and you were actually awarded a government grant, a pretty good size one, to continue developing this in 2023, I think. Right? Tell us a little about that.
Yeah, sure. So I actually have a prototype here if you'd like to see it.
Yes.
I'm entirely fine with other people seeing it as well.
Okay.
So this is not one of our most recent prototypes, but this
So it
is sort
looks
of
like
what
a
it looks
box.
like. Yep. Pretty uninteresting box, to be honest. What's important is the structure inside of this box.
Okay.
So if I take off this here, you can see that there are pockets inside.
Okay, got it.
Um, and then we put this together, and then so this entire assembly would be pressed in between joists of a house,
So
of the wall of
this,
a
what
house.
you're holding, that's the actual insulation.
This is the actual insulation.
There's so much air and so much space in between those panels in there.
Yes, there is, and that's
But
by
that's the
design.
point, right?
So we figured out exactly the right geometry we need in order to prevent the circulation of air within the pockets. There are three main types of heat transfer. At least if you ask an engineer, there's many more, but the three main ones are conduction, convection, and radiation. Conduction is like particles bouncing between each other in a solid object, usually. Convection is a fluid interacting with a surface, and radiation is photons of light being transmitted through open space. This design takes advantage of all three of those properties in order to stop the air from circulating as much as possible in order to prevent the convection. We don't have a lot of material in here, so there's not a lot of conduction. And we have reflective surfaces that have been exactly formulated to make sure that as much thermal radiation as possible is reflected back towards its source. So those three things together make it really effective compared to conventional insulation.
And so how do you, here's a really dumbass question. How do you know it works?
So I built this huge machine in my bedroom because we don't have any other space at the moment. That it is a thermal test chamber where we have a heat source in the center. It's very well insulated on the outside, and we have a bunch of thermal sensors throughout the chamber that can record how heat changes over time and heat flux and the temperature, all sorts of fun stuff like that. And we're able to put in insulation with known quantities, like stuff like fiberglass or foam insulation, and compare it directly to how our product is performing. And you don't have to take our word for it. We've also got at least one of our our first prototypes ASTM certified already. ASTM is like the governing body of engineering measurements. And they agree with us that our product is at least on the right track. Right now it's at about 4.0 R per inch certified and up to a little bit over 4.5 R per inch from our current experiments.
So I think what you just said in English is that
Sorry.
it's okay. The agency or the body that certifies the effectiveness of insulation has essentially given you a stamp of approval that it's almost or just as good as commercial as installation that exists now.
That is correct, yes.
So it's ready to go. Is that what you're telling me?
Not quite.
No?
We have a lot more testing we want to do first.
Okay.
We want to make sure that it is holds up to flammability requirements. Obviously, if we're going to be installing this in people's houses, we want to make sure that it's safe to use. And based on our current understanding and our thermal experiments that we've done and combustibility experiments, it does seem to be the case, but we want to keep trying to make sure. We are also working right now on the manufacturing side of things and getting the manufacturing line up and running. Currently, we have to make all of these bats by hand, which is a very time-consuming process.
Sure.
It would not be and economically feasible without some automation. So we are also working on automation, and that is what the grant was for that you mentioned right at the beginning there.
Okay.
We last year we received one of the most prestigious grants in the country, which I'm very proud of. It is a National Science Foundation Small Business Innovation and Research grant. Yeah, they looked at our product and said, that sounds like a great idea. We'd love to see where it leads.
Well, that's really awesome. You keep saying we. Do you have a team working with you here, or is this all you in your bedroom?
Not entirely me, no. So I currently have 2 employees who are helping out. My automation engineer is Zoe Katz, and our laboratory assistant is Mabel Fox.
Now, on your website, which by the way is owlflyllc.com, right? An owlfly is, of course, an insect that's very beautiful. And if you guys want an explanation on what an owlfly is, that's all at owlflyllc.com. There's this delightful 2-shot. There's a photograph of you, black and white photograph, you on the left with old-fashioned insulation with a look of disdain on your face. And on the right is you holding up basically what you just held up now, which is a prototype for Yellowjacket. When do you think that we'll actually see Yellowjacket at Home Depot and Lowe's?
Home Depot and Lowe's is a stretch goal for us. We want to start out with individual homeowners and working to make sure that we iron out all the kinks before we scale up to large distributors. We are hoping to have a manufacturing line up and running within the next few months, and I've been saying that for over a year at this point because things keep coming up. We want to make sure that this product meets our expectations before we release it to the market. But hopefully within the next few months, we'll see.
It sounds like you're doing everything right, step by step, and you're making sure that you're making sure, which sounds to me like, you want to make sure that all the I's are dotted and the T's are crossed before you actually. How do you go about setting up manufacture? Do you have to find a company, or do you create a manufacturing process, or do you find somebody who already kind of does this and then you give them your patent and say, here, make 1 million of these, or how does that work?
So no one has done this before,
Of
which
course.
makes it difficult to find someone who could do it for us.
Mm,
So right now our biggest hurdles is finding manufacturing space in the area that is within our price range,
mm.
and designing the equipment we need in order to automate the process, which are two major hurdles that we're making good progress on. Um, Two other things I want to highlight
Yeah.
about what makes this product different from other stuff that's currently on the market. Um, as you were seeing before, I can handle it with my bare hands,
Hmm.
which is very different from the industry standards of fiberglass and spray
Right.
foam.
Sure. You have to put on all kinds of,
Um,
so you don't want to be breathing in the fiberglass, right?
exactly,
Yeah.
yeah. Another really cool thing about it is that it can actually flat pack um, when you're transporting it, and then when you're ready to install, you just
Oh,
click
that's
it into
cool.
position.
Yeah.
There's two little inserts that go on the sides. But it's entirely like compatible with like DIY. You don't need any PPE for it. I just wanted to put that out there. Something else I'll be
Yeah.
proud of.
No, that's cool. Your website also has this dandy little animation that shows the different ways you can apply the panels. There's small panels that you put in between the studs, and then there's bigger ones that you just kind of slap onto your 16-inch space, I guess, or whatever. You guys you've obviously thought this way through. I'm guessing it's going to be sooner rather than later that we see this stuff out there. So you had this other. Actually, the first video that I saw is a product that you're not actually developing. This cool little it's kind of an Uber windmill. I think you call it a wind turbine. I found this little video of this thing turning. I think you made it from a bunch of umbrellas. And here's a shot of you being very excited that it actually works in very little wind. I'm guessing that was the point, right?
Yeah. It so in that summer after I got laid off, my team and I were trying to find we tried out a bunch of different ideas just to see what would stick because, we're engineers, we're creative people.
Yeah, got to do
We like
stuff,
to
right?
try stuff.
Sure.
Um, and we weren't sure what was going to end up being the the thing that is most likely to succeed. So you mentioned the wind turbine. We also tried to develop a type of cardboard out of pond algae, which worked surprisingly well. But there's a lot more development that would need compared to the insulation. Um, uh, the wind turbine was a really fun project, and like you said, we made our prototypes out of old umbrellas that we
Well, it
cut up.
almost looks like a high school science project, but I guess
Mhm.
what was the goal? It was the goal to come up with something that was more efficient than a traditional windmill to create energy.
So, not exactly. Basically, any small scale wind turbine is going to be handicapped for lack of a better word, by its scale. Wind power is calculated as the cube of wind velocity and the square of the spun radius. Which basically just means that the bigger the turbine is and the higher the wind speed, the more power that you have available
Sure.
to get out of the
I
wind.
actually understand that. Okay.
I'm trying here. I'm trying. Um, uh, so when we're trying to develop a small wind turbine, there's only so much possible wind power that you can
Hmm.
get out of it. And that's just a physical limitation that there's no way around. Um, So we weren't really trying to outcompete other types of wind turbines. We were just
Got it.
trying to create a better small one um, that people could use for niche applications, like if you go camping or if you're doing scientific sensor
Something that
stuff off
requires a
grid.
small amount of power, not powering an entire city, for example.
Yeah, but the cool thing about that design was that it was entirely foldable. So like you could fold it up and put it in a backpack and then install it wherever you wanted. Um, that project, again, it was very fun. We think that there is some market for it, but we want to focus on the things that are going to have the biggest impact first.
Sure. And is it true that that wind turbine was inspired by this sea creature called a crinoid?
Yes, it was.
Okay, I'm
So
showing a video of the crinoid. These are like the creepiest looking sea creatures. It's not a fish. It's in the same family as, I guess, the sea urchin and the starfish, right?
exactly,
But it's
yeah.
got all these tentacles, and it looks like it rides on the waves. And so what, you looked at this and said, I'm going to design a wind turbine that does that?
Yeah, exactly. So I was just scrolling social media one day and I happened to find I think probably the exact video that you're talking about. And I just looked at it and I thought, so this creature is using this motion to propel itself through a fluid. I wonder if you could do that the other way around, where the fluid causes this motion
Mm.
in a mechanical device. Um, and I did some research after the fact, and it turns out that every inventor over the last 200 years has had a very similar idea.
Oh, is that right? Oh,
So,
that's funny.
um, I the way I did it is slightly different, so at least I get some credit there. I did make some innovations in the design, but it's not like revolutionary.
Yeah, well,
Uh,
for a schlepper like me, it was cool and it was interesting. So,
oh,
so
me too. Yeah.
that's two inventions you came up with based on essentially nature, natural.
Mhm.
Is that so? You obviously have a talent for, seeing something that exists naturally and making it into something that, hey, we might actually be able to use as humans. I guess the question I would ask, do we humans deserve that? Given the pace at which we're fucking up the planet and the climate and the ocean and the air and all that stuff, I guess we do deserve it. I don't know. But what else do you see down the road? Do you have other ideas like that?
So to address uh that sort of impulse to say like, oh, humans are messing everything up, it's like, yes, that's absolutely true, but humans are also the best solvers that we know of in the known universe. Um, and taking inspiration from nature, I think, is one way that we can try to address these problems because nature is a system that has been evolving to address challenges for the past 4.5, well, 4 billion years. Um, there are some very great solutions to the problems that we're currently facing if we choose to look for them. Um, and I think that's our responsibility, right? If we are causing problems, the best way to address those problems is to learn about them and try to find creative solutions that involve as many different perspectives and experiences as we possibly can. Um,
Fair enough. Hey, let me ask you this. So, my brother-in-law, the teacher, the mechanical engineer, he teaches this class, and he's got girls and boys in this class.
mhm.
Are you satisfied with the number of women, girls who are interested in science and in STEM? Have you seen, your contemporaries, people who are women in college and elsewhere who are interested in this stuff?
So from my experience, personal and through observation, um, the problem is not whether or not women and girls are interested in science. I think most of us are. Um, the problem is just the access to resources and opportunities within this field. There is obviously, a lot of subconscious bias in male-dominated fields that can serve as a barrier, hard or soft, towards women entering and then advancing in STEM fields.
More about
Yes,
opportunity than desire.
exactly.
Alie, I really appreciate you spending time with me. My guest today, Chris Alice Kratzer. We call her Alie. She wrote this book. You got another book coming in the fall, correct? On cicadas.
Yes, I do. It's going to be even better than the first one. I'm
How
really looking
could it
forward
be
to
possibly better?
it.
So, how many cicadas are there in the world? Are there also thousands of those species as well?
There's many fewer cicadas than there are wasps. There's only about I think 3,500 in the world.
Oh, is that
Um,
it?
yeah, that's all. Um,
All right.
my
So,
book will only cover
I have
373
fond
of them.
memories of the cicadas that grew here in New Jersey back in, I'm guessing that big, you call it a migration, eruption, a hatching, whatever it was.
A brood,
It was
yes.
like before 2010, right? Was it like 2008 or 2009?
Mhm.
Yeah. And so I have great pictures that I took of cicadas close-ups, but I just remember that when they were at their peak, the sound they made, it sounded like an alien ship hovering over my town for like 2 solid weeks. And then the cicada shells and the dead ones and the live ones at the base of my tree. Cicadas are, I think that they're fascinating because they're harmless and they're ugly, but they're beautiful all at the same time, I guess. So when's that book coming out?
The hopeful release date is September 1st.
All right, cool. Well, Alie, thanks again. I wish you nothing but the best. I hope you stay cool, and I'll see you soon, maybe at the next book fair, right?
I hope so.
All
See
right,
you
be
then.
well. Good